Okay, I'm very pleased to welcome today two speakers, Team Tangherlini and Lev Manovich, who both were driving figures in the cultural analytics program at UCLA in the spring of 2016, back in the days where you could travel. And where they gathered an enormous amount of people around this subject, which we will be talking about today. We'll hear about some of Tim's new research. We'll hear about Lev's new book, Cultural Analytics. What an apt title for this seminar. So I'm very excited about this. I think it's really important, and all of the organizers, which is not only the Human Futures program, the Future Technology, Culture and Learning Processes at the Pedagogics University of Denmark and the National Center for School Research. We all think that new technologies to understand culture and understand the large data that we're producing in all aspects of life are really important, whether you do it with traditional statistics or whether you use machine learning. These data is out there, and we cannot ignore them without willfully ignore what is actually some of the most important fabrics of culture today. So with that, it's a great pleasure to introduce our first speaker, Team Tangherlini, who is a newly appointed professor of Danish literature and culture at Berkeley after having spent many years at UCLA. I've worked with Tim in a number of occasions, and it's always a great pleasure to have you in. As we said, it would be even greater to have you at Aarhus, but this is, of course, much more easy for a short talk. And we look much forward to hear your both definitions of the field of cultural analytics and one of the projects where you have shown that you can discover things with network analysis, with gathering of large data sets in a way that you couldn't just do by hand. So with that, Tim, a warm welcome, and the floor is yours.
Great, thanks, Mats. And I was muted. I apologize for that. It's wonderful to be here in Aarhus, albeit virtually. A little bit easier to just walk to my office with a cup of coffee than to jump on an airplane. But that said, I miss the hygge of being in Aarhus and in Denmark. But I'm glad to see that so many of you have either woken up early or taken the time out from your regular part of your day or have stayed late to be part of this. And I'm looking greatly forward to hearing your questions and your discussion, and also hearing from Lev. I'm taking a slightly sort of broader view of my remit for today. I'm going to talk about culture analytics and the real fake world, and particularly looking at the rise of conspiracy theories that we're seeing in social media, everything from the rise of something called Pizzagate in the United States to the both the anti-vaccination movement, but even more important, the COVID-19 conspiracies that are circulating, and then of course this one conspiracy theory that aims to rule them all, called QAnon. Before that, I want to jump very quickly in and talk about these problems that we came up with at Lake Arrowhead in our final meetings in 2016, 17, and 18, because culture analytics had a long tail, and it has then prompted a lot of people to continue working, and we can't take credit for all of the work, but we do hope that some of these problems are ones that help you think. They could be used as heuristics in some ways, and we came up with 7 open problems for culture analytics, which we see as the data-driven analysis of culture. So what are the basic objects of study and concepts which can be subjected to formalization? Because if we're going to do computational work, there has to be some sort of formalization. what are the essential measures for cultural analytics? What constitutes a successful mathematics of culture? And so these are things like looking at how culture changes, how it can be described, how they are both dependent and interdependent. What are the fundamental structures of cultural interdependence? What are the fundamental dynamics of cultural change? And I saw Christopher Nirpo is on the call, and he's really been looking at this a great deal. What are the algorithms that can detect the structures and dynamics of culture? And in our own very little way, that's what we've been looking at with network analysis and narrative structures at internet scale. And then, of course, and this is very important, what are the ethical challenges in culture analytics? And we've been certainly in the United States seeing this as a major focus of concern, particularly in the lead up to this very crucial election that we have next week. There's amazing work in the past few years. We're going to hear about Lev Manovich's new book on cultural analytics. If you're not already aware of it, there's a wonderful journal called the Journal of Cultural Analytics that a lot of people are submitting fairly cutting edge research to. And a lot of these projects are just getting off the ground. So there's a lot of room for debate, and there's a lot of room for improvement. And there's a lot of room for thinking through approaches to extremely complex issues. That's one of the things that attracted me to UC Berkeley, with an entire new school dedicated to data science, and it's called Data Science and Society. And so I'm hoping to be part of that. That's one of the many new centers, programs, and workshops that are focused on this data-driven analysis of culture. And then I would be remiss if I didn't mention the Interacting Mind Center, where lots of very interesting work is being done and being driven in part by all of the people like Matt's who are bringing focus and attention to culture analytics, not only at a local scale, but really at this global scale, where we can make a lot of contributions to understanding human expressive forms over time and across great expanses of the world. Here are some of my areas that I'm very excited about, that I've been poking at over the past 3 or 4 years. Dynamic data and real-time applications. So how can we analyze data as it comes in real time? Are there algorithmic ways of doing this, as well as certain predictive algorithms that say, given this, what do I expect to be happening next? We use this in the context of the circulation, the generation and the propagation of rumors, which thrive in these very low information, low trust environments that, at least in the United States, we seem to be living in at the time. Multilingual search and analysis. There's a really incredible project called Book NLP that David Baman at the Information School at Berkeley is leading, and that's an approach at looking at structures and devising tools to work at scale with fiction from any kind of linguistic tradition. Visual data analysis, we'll hear more about that, I'm sure, from Lev, because of his cultural analytics lab does a lot of this work. Pete Broadwell at Stanford has been doing some excellent work in this area. And then, of course, Peter Leonard at Yale. And then social media analysis. I think the Observatory on Social Media, awesome, at Indiana University is a great series of tools. It's a wonderful observatory if you're interested in things like the Twitter sphere or TikTok or Instagram or all of these rapidly changing social media environments. Somebody once said that when I give a talk, I really should focus on the things that I know, so I don't get myself into difficulties. So I'm going to talk a bit about my current work and some of the things that we've done that hopefully don't reveal the depth of my academic or intellectual attention deficit disorder, but rather cohere perhaps into some sort of theoretical corpus. A body of work that I've been doing with people in Amsterdam and in Germany is multilingual search across very large collections of legends, which are told as true stories, sound in Danish. So we have these very large archives, hundreds of thousands of stories from each of these different traditions: Dutch, Frisian, Danish, and German. And the idea, of course, is to be able to search in one language and retrieve results in many languages. And so we've developed a multilingual domain tuned to search across cultural archives. So here you can see that we're searching in English, but we return from these three archives 6,000 results of stories about witches. And then we can reduce that to 412 results where witches do something with butter. And we can see that butter seems to be on the minds of most Danish farmers in the late 19th century, for good reason, it turns out. We're extending this now to include Iceland, Norway, Sweden, possibly Finland and Ireland in the next 3 to 5 years, because of the work that we've been doing in zero-shot translation using neural machine translation models. And we're actually getting some very good zero-shot translations. Danish to Swedish, for example, is almost human translation level. And so this allows us to do dirty translations and search in one language and find the equivalent records from other languages. So then researchers can work with much greater recall, not only in their own language, but across many languages. And one of the ways we do this is we do multilingual language embedding. So I made a little video of this multilingual language embedding space, and the visualization is just too beautiful not to share. So first we're going to look for a Danish witch, and it should show us where the Danish witches are. And so the Danish witches are there, and we can see that they've got various things associated with them, including priests and what did I see there? Kællinger, and even hidden folk. The American or the English witch is embedded in a slightly different neighborhood for reasons related to the language model, which we're trying to create a little less distance between them by tweaking the embeddings. But here we can see Danish butter and English butter are very close to each other. And so that means that we're likely to get through these embeddings some very nice domain-specific translations that are very important for very specific types of collections, like collections of folktales, where the languages used in them are not those of normal language. Another great deal of work that I've been doing is on character interaction networks, where we try to understand the interaction of characters, not just from one work, but across a large corpus of works, something like the Icelandic sagas. This has led to some very interesting experiments with how do we visualize the complexity of character interaction networks. And so the International Graph Drawing Competition took some of these networks and put them out for competition, along with our work on K-pop interaction networks. And we're starting to see some very interesting ways of visualizing complex data that actually gives us more information through the visualization than simply drawing a pretty picture. So the visualization is also a research tool in itself. They can also be quite fun, like this visualization based on a runestone that you can actually cut out and fold. But on the runestone are all of the per chapter character interactions in Rappenkel saga. We've also been working on ways of using visual analytics as a way of generating a search engine that doesn't use text, but rather uses the visual input. We're very interested in K-pop dance because it has taken advantage of all sorts of different types of dance from many different traditions and incorporated into one. So this would be a perfect test bed for understanding propagation of dance moves, but also understanding influence in dance moves. And so the first thing we had to do was, of course, figure out how we could isolate both dancers and dance moves. And so here's a little experiment, the beginnings of our search engine for K-pop dance. And so you can see we've got already it's searching basically just on itself. What are all of the poses that are similar? And eventually the goal is to have a series of poses as a dance move and then a series of moves as a dance sequence, which can then be fed in as show me all of the other videos that have this, and those could be timeline. So we could now get a time delimited search for a particular dance pose, dance movement, or dance sequence over the 12,000 videos that we're working with currently. The other thing that I've been working with, of course, as you're starting to see that I like networks, so I work a lot with networks, is trying to understand very large classification schemes and the embedding of particular corpuses in those schemes. So this is all of the various classification schemes dreamed up for fairy tales, and then the 4,500 or so Danish fairy tales that have been classified according to those schemes. So what was a tree structure becomes distorted by the embedding of the Danish stories into that. And the goal is to find two things. One is some sort of implicit spine to the network by peeling it and finding the different levels of connectivity in the network. And then for each of those levels, finding pathways through the network that if you start at one point and end up at another point that is a long path through the network, you're going to learn something about that network. And if we have information on the edges between nodes, then we could in some ways create a story of traversing that network. And so I show you here a little bit, we decompose the network, and this is at a certain level of structural similarity for all of the nodes and edges. And then we start to find these long paths through the network, and along those long paths through the network, we're going to find some label edges so that if we read them according to one pathway, we're going to get a story of one of those spines. You can see those highlighted pathways, and those highlighted pathways are really the spines in the network. So this part in here, this long path, is telling me something about how that particular level of the network is connected. We're also doing this for something even bigger. We took all of the keywords in IMDb and did the same type of decomposition, but here we have millions of keywords and tens of thousands of films, and we can see these remarkable structures that tell us something about all of the films in IMDb, as well as the way people conceptualize those films. And so we decompose this network, and now we're going to try and find the semantic spines in the network by using these paths through the network once we've done the decomposition. Otherwise, you just have a giant hairball. The thing I've been spending most of my time on, though, is conspiracy theory. And we started this by looking at what is the difference between a conspiracy theory, which is fictional, right, which is an account that people want to be told, and an actual conspiracy, which is something people don't want to be told because it's illegal, right? And there are actually people doing this. So malign actors covering up their activities on the one hand, and on the other hand, conspiracy theory is a purely narrative endeavor. So our first work was on discriminating between fictional conspiracy theory and real world conspiracy. And we were lucky we had these two things that happened more or less simultaneously. One was a political payback operation called Bridgegate, where the governor of New Jersey conspired to shut down the George Washington Bridge, one of the world's busiest bridges, for 5 days to get back at a mayor he didn't like. And the other one is Pizzagate, where the story goes the Democrats, and particularly Hillary and Bill Clinton, were involved in a pedophilic, cannibalistic, satanic child trafficking ring situated in the basement of a pizza parlor in Northwest Washington, D.C. That became known as Pizzagate. And so the first thing we did was just generate what we call a wall of crazy, doing some extractions from all of the discussions of Pizzagate on Reddit. We just looked for named entities and whether or not they co-occurred with another named entity. And we got this incredibly complex graph, which you're familiar with from Danish or other Nordic noir television series, because every detective has one of these walls of crazy when they're trying to solve a murder. We thought, wow, that's really crazy. Let's do the same thing for the real world conspiracy. And that's the wall of crazy for something that actually happens in the real world, where you simply find the actors and all of their connections. So we started to think, well, actually, the real world might be a lot messier than fiction. So I backed up and I went to my go-to corpus, which is the corpus of Evald Tang Christensen, a very well-known Danish folk collector from the 19th century, who obsessively collected stories from farmers and other day laborers throughout Jutland for about 60 years, among them thousands and thousands of stories of witches. And I wanted to see if I could somehow or other decompose these stories and come up with a wall of crazy that is the underlying generative narrative framework for Danish witches. And I could, and the other thing I discovered was that this broke out into different domains of interaction. And so it became very clear that these complex legend storytelling, where stories of witches might have just farmers and witches, there are other stories that have farmers and witches and Lutheran ministers, or witches and manor lords and so on. And what they were doing was that they were layering different domains of interaction and creating a legend complex, which is very similar to a conspiracy theory. So we devised a pipeline of interlocking computational methods using natural language processing and some machine learning. And we set our sights on Pizzagate to see if we could match a hand-drawn New York Times graph, because we knew we were going to come up with a network representation that was going to be the narrative framework defining all of the realm of storytelling for this conspiracy theory. And yes, we were able to match it automatically, computationally. We missed cannibalism because at the time, cannibalism was not very important. But the New York Times liked it because it's visually arresting. to see Hillary Clinton and cannibalism in the same graph. We found cannibalism, it just wasn't highly mentioned. What we did find was very highly mentioned among the Pizzagate people was the Clinton Foundation and Bill Clinton. And so those were highly ranked in this graph. And that actually is very important. And the New York Times kind of missed that. We also get very fine-grained detail on the different actants in this graph. So we can tell you that John Podesta also follows Satanism according to these conspiracy theories, that Tony Podesta's Weird Art uses a secret coded language to talk about pedophilia. And so the Weird Art promotes this. And we do this at an aggregated level. So over tens of thousands, if not hundreds of thousands of social media posts, a single post might just say, Tony Podesta has weird art. And so taken alone, it would just be a tuple and not that interesting. But when we aggregate them, we wind up with these very complex, multi-domain narrative frameworks. The other thing that we started to wonder is, how is democratic politics, Podesta brothers, casual dining, and Satanism connected? Because in the real world, they're not connected. They are in the aggregate graph. If we project these four domains onto a single plane, we see that the graphs are not connected. It's not until the conspiracy theorists come up with WikiLeaks that you see, if when I add in WikiLeaks and I project it onto the plane, all of a sudden things that don't seem to be connected are connected. Well, that's the whole point of a conspiracy theory. I've got secret knowledge, I've got hidden knowledge, I've got great powers of interpretation, and I can connect things that otherwise were unconnected. What's interesting, so that's always been hypothesized that that's how conspiracy theory works. What's interesting is that our computational methods picked up on this automatically and with very little human intervention. So yes, we can find a structural feature of conspiracy theory that sets them apart from real conspiracy, because real conspiracy doesn't have that extra plane of interaction, the interpretive plane that brings the graph all together. In fact, a real conspiracy, one of the things we discovered was that the graph is robust to deletion. We could delete very important nodes in that graph and the graph would stay connected. And so that becomes a structural feature that helps us distinguish between conspiracy theory and conspiracy. So then we turn towards all of the comments and rumors about COVID-19 that started to be unleashed on the internet in March. People were trying to figure out what is going on. And what's important is that in low information or low trust environments, people tell stories. And so here, there was an opportunity for lots of rumors to take hold and start to align different domains of interaction. And that's why we got a proliferation of conspiracy theories. We saw new conspiracy theories. We saw new conspiracy theories merging. We saw brand new ideas coming into existence. And we got big conspiracy theories like QAnon that were trying to embrace the entire world. And then we found a very interesting thing, the interaction between conspiracy theories and the news, which at the start of our work was over 2 weeks long. We could measure this very slow undulation, but as the virus took off, the undulation got closer and closer, and pretty soon they were just undulating together. The difference between the news and the times that that was picked up in the conspiracy theories, and then the news picking up what was being talked about in the conspiracy theories, was reduced to something so small that we couldn't measure it. What we did find was we found this very broad area of different types of narrative frameworks in our community detection. We use community detection to break out these different narrative frameworks. We found 30 very large ones, 4 main ones, a bunch of little new ones, and then some meta-narrative communities. But what was interesting was to see which meta-narrative communities were sharing so many edges that they were more merging into one. One was the Bill Gates vaccination global surveillance state, making use of 5G, a malicious vaccination project, and a virus that may not actually be a virus at all. The other one was this Chinese bat one, we call it, where the bat was either the initial vector or was being studied in a lab, and the lab's permutations of the virus were then released back out. So this is evil kind of Dr. Jekyll, Mr. Hyde, evil scientist kind of stuff. The bioweapon, where the Western governments are fighting the Chinese Communist Party, and it's only through a researcher soldier who, through an anonymous source in China, is able to reach these Western governments, and that it really is about bioweapons, and that's what the virus is all about. Or another one, that it's a hoax, that Trump is fighting this Wuhan hoax. It's part of a Jewish conspiracy cabal, and because it's a hoax, you should go film your hospital. It's as much of a hoax as global warming is. And now we see another one. This is a nucleation, where the test is not really a test. It's a way of infecting millions of people very quickly, that it's the test itself that is causing the cases. And this is kind of an interesting interpretation of when our lovely, what do we call him? The president, I guess, says that we're getting more viruses because we're testing more. So, I don't know. People are funny. People are funny. That's one of the things that we've discovered from all this work. And then, of course, this has led us to look at QAnon. And we've now got a big graph of QAnon that we're working on. This is from, what day is today? Tuesday. This is from work this weekend. So we're finally getting graphs of QAnon. This is Q here and his first neighbors. And these other ones are Trump, attorneys, and politicians. So even from this graph, we can see what Q is all about. And even though Trump says, I know nothing about QAnon, it's a 2-degree relation between Q and Trump, at least in the storytelling of all these conspirators. So what can we get from this work? We can identify the important actants and their interactant relationships. We can construct a narrative framework that presents a multi-scale representation of narrative space. And we can identify network features that may help us determine whether something that's being talked about is an actual conspiracy or if it's conspiracy theory. And that might give us ways to attack conspiracy theories. We can devise strategies for pointing out nodes and relationships which are based on fiction. We can understand what people see as threatening. Where do these threats come from? And then why do you choose these strategies that you might take? Remember, in Pizzagate, a guy in North Carolina said this was so dangerous, he jumped in his pickup truck with an automatic rifle and drove hundreds of miles through the night to Washington, D.C., and broke into the restaurant, the pizza restaurant, while families were sitting there eating their pepperoni pizzas, and started shooting his rifle because he wanted to find the underground tunnels in the pizza parlor. When he discovered that the pizza parlor was built on concrete slab, there's no basement, he surrendered to the police. We had another guy, a follower of Q, load up a van with dynamite and drive onto the Hoover Dam, one of America's biggest dams on the Colorado River. So it's hugely important to be able to do this. So I'm going to wrap up here by saying thanks to you, my very patient audience, NSF and IPM's long program in culture analytics. My co-conspirator in chief is Pete Broadwell at Stanford. The group that I work with on narrative frameworks is Vwani Roy Chowdhury, another one of the co-conspirators for the culture analytics long program. Some great graduate students, Shadi Shasavari, Pavan Holler, Chani Wang. And then on these large decompositions of very complex networks, I work most closely with James Abello at Rutgers University. Thank you.
Well, thank you so much, Tim. Thank you for this wonderful presentation, and also for showing that there's certainly a political side to cultural analytics, a more than just nice to know, but sometimes a need to know, going from Danish folklore to things that are happening right now, and where you say, well, it's a big crazy world out there. I will look forward to discuss that. We have time in the Q&A, but I think we should move on to Lev Manovich, who has already posted some comments in the about how conspiracy theory and humanities theories could be thought of as being alike. I think that makes sense in a lot of ways. But first off, we're very happy to have you here, Lev. When I wrote you, I thought you were based in for this semester in New York State, but you happen to be in Korea. So even more, thank you for taking the time to be with us here today, despite the time difference. Now I hope that he's still in the room.
Yeah, I'm here. I'm in the room.
You're here. Oh, great. Thank you.
I'm here.
And just by way of introduction, Lev Manovich is the author of numerous books, the language of new media from 2001 being one of the most important. And as with the new book, which I'm halfway through, it was published last Tuesday. It feels not just as a very, very smart, learned book, but also as a very encouraging book that gives you concepts and ideas to think with on your own. So congratulations on your new book. And we look much forward to hear your presentation of it and have a discussion afterwards. So with that, Lev, the floor is yours.
Thank you so much for this invitation. So indeed, I was lucky to be able to move with my wife, who is actually from Korea. We were able to kind of fly to South Korea in the end of March and have been residing it since that time, and kind of watching with a bit of a horror, right? What happenings back in the States, or at least in New York. I think California has been doing better. So I think Tim was very wise not to take some job, in the East Coast like I did, but to wait until he got the best offer from Berkeley. And I have to say, when I heard this, I had two ideas. First of all, Tim is really, to me, he's really a pioneer. He's one of a few humanities people who is doing a work, right, which reaches from Scandinavian folktales into conspiracy theories. He publishes, papers both in his own field and in computer science. And to me, right, he's not a youngster, but he's very young, to the extent that I think he's really a kind of avant-garde figure who shows us what future humanities can be. As we know, humanities have been under attack. The enrollment, right, in humanities, especially in the States, have been dropping, and you can't blame people for it, right? Because in contemporary world, people want to have jobs, right? They want to have some practical skills. And I think if more people will start, and more students will start doing what Tim is doing, I think humanities can be in a very healthy shape. So today's talk is a kind of landscape of just amazing work he has been doing the last few years, and which kind of bridge between the narrative theory and other concepts in study of folktales, anthropology, kind of narrative theory, and contemporary kind of social media landscape. It's also inspiring. Now, before I kind of tell you a bit about my own work, what I've been doing the last few years, I have to say that because of the time difference, it's after 1 a.m. I seem to be widely awake. This is not the latest time I've been giving talks in Europe, but my talk will be a bit modest. I will not try to introduce any new ideas because it is 1 a.m. and it's very possible to very quickly to sleep from theory to conspiracy theory when you're like late at night and your mind is disconnected from reality. So before I do what everybody else does in the situations, which is share the screen, I want to show you something which I think is very precious these days, a physical book. So here it is, ta-ta. I have to say, that it is, I think, a beautiful object. They did a very good job. Nice cover. The font is very readable. and I don't see any mistakes in printing. And I wish I can be with you and kind of give everybody a copy of a book, but I clearly can't do that. But perhaps I don't know if university libraries still buy books, but if you don't want, you can get them to buy a book and then maybe just steal it and take it home if you like this object on your bookshelves. So let me share the screen and tell you a bit about kind of my vision of cultural analytics, which I never claim is the only vision or the right vision. Like what I've been trying to do in my work for the last 15 years is both observe the growing and changing landscape of lots of centers, lots of people, both in academia and outside, designers, artists, computer scientists, human and social scientists doing work, which is connected to using data and quantitative methods to study culture, but also kind of in a way, follow my own path of my own interests. Okay. So here we are. Okay. So this is the latest PDF I got from MIT before the book was published. And I want to do kind of a few things. First, I want to tell you about the structure of the book, how it's organized, and what is the intended use and conception. And then I want to tell you about things which in fact have been on my mind in the last couple of years, which appear in the conclusion of a book. In some ways, it's like a critique of a book. And it's really about what I think I'm perhaps, from my point of view, are most interesting, most difficult challenges, among other challenges which come up when we think about culture, big data, and computation. Right. So in putting together this book, I've been using my own experience of getting students to learn about data visualization and how to use them to study culture. The book itself took 15 years, talking about, a little project. I remember very clearly when I was in my apartment when I had a residency in Rotterdam in the fall of 2005, and it was a rainy evening in November. And literally, like I got this light bulb in my head, and suddenly I got this idea about what if we start using, the computers, which we're getting faster and faster, and we're getting more and more RAM, and we already existing methods in computer science. The term data science didn't really exist, and the abundance of digital culture, which already existed by 2007. The social media was just becoming to be popular, but it was not very big. Flickr was the only big network, but you already had millions of websites. Every university department, museum, designer had a website. People had blogs, and it was already Flickr existed, and it also was already possible to add images to blogs. So I thought, what if we put it together and create a kind of interfaces, tools, and methods for the observation and analysis of contemporary culture at scale. I was also interested in historical culture, but the contemporary culture and its unprecedented scale was my motivation. And then I've been teaching, started to teach this. At that time, I was a professor at the University of California, San Diego, teaching digital art in a visual art department. And then in 2013, I moved to New York and became a professor of computer science at the graduate center, which is a part for PhD and master students at CUNY, City University of New York. So I became professor of computer science, and with a kind of feeling of horror, started to teach PhD students in computer science. I've never taken a single computer science class in my life. In fact, 11 years ago, I didn't even know how to use Excel. So 10 years ago, I learned how to use Excel. And when I taught myself R, and when I got this job, of course, I was hired not for my computer science skills, but for other things I've done. But it turns out, that I was able to teach my students in computer science. So that was quite interesting thing. So to hear how the book is organized, and I'm not sure if you guys can see it, I can make it a bit bigger. Can you see the screen? Yeah, good. So there's introduction, and then there's the first part, which kind of tells you the story, how the culture has become big data, and kind of motivates the need to turn to computational and visualization methods to observe both historical, right, but particularly contemporary culture. So from new media to more media is the title of the very first article published about this topic. It was written in 2007, 2009, and it appeared in the Italian design magazine Domus. And the title and the article was called "From New Media to More Media." Right? So the idea was that in the 1990s, new forms of computational culture become viable and popular. So my own book, The Language of New Media, which was written, put together at the end of '99, was the kind of observation of this decade. So talking about the new aesthetics of CD-ROMs, websites, interactive installations, and connecting them to history of design, art, cinema, theater, and so on. And a few other things, of course, happened in 2000, right? We had wonderful new projects building on top of a web, such as Wikipedia. We had the arrival of mobile computing, so the location became a new type of media. And then towards the end of the decade, laptops and phones became reasonably cheap. So we have many more people using them. And then, of course, following iPhone, the phone quickly turned into full-blown multimedia network device, right? But another part of 2000s was, of course, arrival of big data, both as a kind of practical phenomena, but also as a new symbolic phenomena, defining early 21st century. The arrival of the term data science, which already existed, but really came to the surface, I think, around 2009. Already many methods and subfields of various fields existed to analyze data. The cluster analysis, principal component analysis, multidimensional scaling, linear regression, all the stuff existed for decades, as a part of kind of different fields, but now it was all brought together under this new fashionable rubric of data science. And in fact, for better or for worse, this new term machine learning, which before was applied to very particular methods, started to be applied to kind of everything, which I'm not sure is such a good development because it perhaps masks the differences between lots of different methods. So then in the second chapter, the science of culture asks, so if we imagine hypothetically, right, as a kind of intellectual experiment, a kind of science of culture, what kind of science will it be? First of all, why is it kind of even meaningful to talk about this? So I basically say that when you have billions and billions of cultural artifacts being created by billions of people every day, blog posts, Instagram images, people create new layers, right, in games, TikTok, and so on. I mean, think about millions of news articles being published by our outlets. So at least in the digital realm, to a certain extent, the scale of culture is approaching the scales of physics, right? So think about your maybe student years. If you're my age, there's a new movie which comes out, there's a new book which comes out, there's a new article which comes out. Everybody goes to discuss it. Everybody knows it, right? So it's like a small network, and the new important cultural artifacts, everybody knows them. And today it's kind of really very, very hard to follow any cultural field, whether it is globally or in any country. So of course, the scale of culture is not still the same scale as the scale of physical world, right? So there are probably more atoms in a grain of sand than all the images on the Instagram, but it's kind of approaching or maybe already surpassed the scale of the human brain with its 100 billion neurons, right? So already in 2009 or 2008, I started to ask myself these hypothetical questions. So if we are to create some kind of observatory interfaces or computational models, which will try to analyze every cultural artifact being created today, and perhaps try to predict the cultural trends for the next 2 months, 6 months, 5 years, 10 years, and so on, how much computing power would we need to have? And I thought about neuroscience because I studied neuroscience when I was young. So I have a master's degree in kind of visual science, mathematical modeling of visual perception. And I thought, well, there's a single human brain, right? 100 billion neurons, lots of networks. I mean, probably to study contemporary culture would be much easier, right? Because as well as we are in humanities, right? No, there's no such thing as uniqueness. There are very, very few people in humanities or art or design or architecture wholly original, right? So while there are billions of artifacts being created and shared today, most of them are copies, right? So one of the very interesting projects, which I think maybe somebody can do, maybe only Tim can do it, because he's one of the few people who says, I'm going to do something, even if he does it and publishes paper, right? Would be to estimate what is the percentage of original content versus kind of copies floating on the web today, right? Think about all the people on Medium and other platforms which are constantly publishing it, another article trying to explain what neural networks simply talk about track attention. And of course, there's no original content in all these articles, right? Of course, we'll have to separate what's a copy, what's not a copy. It will get very interestingly and delightfully complex. But in general, you know, the contemporary culture perhaps doesn't have a very big complexity because there's lots of redundancy. So then there's a third chapter, which perhaps is one of the most important, and it basically says, well, what we need to understand is that in humanities or social sciences or professional fields, we have a choice of using or not using computational methods to study historical or contemporary culture, but we have to recognize the fact that the kind of cultural analytics, or what I call in this chapter media analytics, has become the new logic of modern media. Right, so we had the mass media in the 20th century, when there's a kind of network media, participatory media, right? All these concepts are still with us, you know, right? We still have mass media, people still watch, you know, CNN and so on. But a big shift towards the end of in the first decade of 20th century was the arrival of what I call media analytics, right? Where millions of songs, you know, millions of films, billions of YouTube posts, Instagram images, and so on, are being processed, right, using techniques of media computing by the companies, and that's what drives search, recommendations, and so on and so forth, right? So, for example, Pinterest analyzes all its images, and that's why you can select the image and then find the similar images. Google does the same, and so on and so forth. So it's kind of the use of kind of media analysis has become a new logic of kind of media and culture industry. So this is the first part, right? So then the second part deals with what I came to believe is perhaps, again, this is, remember, I'm not giving you the definite guide to cultural analytics. This is only my own path through this landscape of research, right? Just one potential version designed to complement other versions, right? So Tim can have his own version. The Journal of Cultural Analytics people can have their own version. The more versions we have, we feel the better, right? So the second chapter highlights particular topics, which I think to me is maybe central to cultural analytics. So I kind of came to think, maybe wrongly, maybe not, that once we can represent the cultural process as data, once we have our data sets, you know, our spreadsheets, our MongoDB database, our network representations, our 3D models, the actual technical methods of analysis are not really different from what we use in other fields when we analyze data. So, you know, cluster analysis, you know, classification using neural networks, regressions, hierarchical trees, and so on and so forth. You know, these are the methods developed in statistics and mathematics and what's now called machine learning over many decades, and also more recently. And the same methods are used right everywhere. So machine learning is the new universal kind of cognitive language, right, of our time, the way calculus, you know, or English or Danish or sort of, you know, other languages have been universal kind of symbolic systems, right, of previous times, and they still are. So machine learning is the universal language of our time, and I'm actually not sure that cultural analytics, as of now, has any really unique kind of technical methods of its own, although I very much respect and support, you know, kind of, I think, Tim's vision, that at least into his 2016 amazing UCLA Institute, which some of us have attended, which to me was really one of the most amazing intellectual events of my life. I think he put the focus on the idea because he was collaborating, right, with IPAM, the Institute for Mathematics at UCLA. He said, well, one of the things about studying culture is that it's not simply about applying existing methods, but hopefully it's also about challenging them and developing new mathematical and computational methods. And, you know, maybe this method developed, but I think by and large people use existing methods. So then what is really so special about cultural analytics? So I think perhaps what is special about it is that a very object of study, which is culture, cultural processes, cultural artifacts, cultural behaviors, cultural experiences, this elusive thing we call culture. So that's why the second chapter is kind of central, right? The second part is central to the book, and it's called representing culture as data. So how do we move from this thing called culture to this thing called digital data, which is what computers can understand, compute, think with, and work on. So I talk about types of cultural data, which of course are not only artifacts, but they also behaviors, which leave digital and physical traces, whether it is recordings of wide movements of people going from museums, or our likes, or navigation through the web. I talk about how to represent interaction. And of course, the interactive media is the media of our time. And of course, cultural analytics, as all of humanities, haven't really dealt with it that much, right? So we're still analyzing, text and networks and images, including myself, but we're not really analyzing that much, using computational methods, video games, or interaction. In fact, the industry is the one which analyzing interactions more online. So we kind of haven't really quite, I think, dealt yet with defining media of our time, which is interaction. And also I talk about events, places, and organizations as another kind of source of cultural data. In this, in particular, refers to my current project, which I call Elsewhere, which has also been going on for 4 years, where we collected data about 4.5 million of cultural events in 200 countries and 22,000 cities worldwide. And the data comes from a number of global platforms where cultural organizations and also individuals advertise and describe their cultural events. So we collected data from Behance. We collected data about 30,000 TEDx local meetings. We collected data from 2.5 million meetup meetings and a few other platforms. And for the last actually few months, I've been looking for smart computer science collaborators to work on it. Perhaps I'll be able to work with some computer scientists in the Korean city where we live in, because it has a university called KAIST, which is known as Korean MIT. So the top Korean computer science students are here. So Thursday, I'm going to meet them to see if we can work on this together, right? So the idea is that the number of physical events, of cultural physical events, became so large that we can look at cultural events, such as the seminar, as also a form of big cultural data. So then the next chapter deals with cultural sampling, one of my favorites. So we all know about the concept of sampling, right, in statistics, and it became fundamental to social science. But how do you sample culture for humanities? Like, for example, right, let's say a country allocates some budget to digitize, the culture of Denmark, or culture of Copenhagen, etc. What are you going to digitize? Are you simply going to go to existing museums and digitize what's inside? But what's inside can be very biased, right? It can be also people who somehow through their networks become important. I mean, what about all the tens of thousands of artists who are living and working in Denmark for the last 100 years, who maybe had some local name recognition, but today completely unknown? I would like to write a history of 20th century painting, for example, which will have tens of thousands, hundreds of thousands of names, and wouldn't have a name of a single important artist. Because why, right? So Wolfen, right, one of the founders of art history, was dreaming about art history without names. I kind of want to have art history with millions of names, but just not the famous names. So how do we, design, right, a kind of valid, democratic, inclusive sampling strategy? Right? So, for example, if I want to represent, kind of fashion culture of, Denmark, of Oslo, I mean, do I simply look at influencers who reach a certain number of followers? Do I look at fashion magazines? Do I stand on the corner and just take a picture of everybody who passes by to capture what actually people wear, right? And so on and so forth. And also in this chapter, there is a very important argument why we need big data to study culture. And of course, the answer is that if we don't really have big data to study a large cultural field, we will reduce it using traditional statistical and data science techniques to the common, right, the most frequent and the infrequent outliers, and what I call islands of cultural content would remain invisible. So then there's a chapter, right, which explains things which I think familiar to many of you, but not familiar to, I think, many of books readers. which is the idea of metadata and features, right? And the fundamental concept of data science, where to represent anything, you represent it as a set of discrete objects. And when you extract, right, features from these objects, whether it is, counting length of sentences, or maybe looking at the number of capitalized words if you're doing if you're designing a spell filter, or measuring, textures, colors, grayscale distributions, presence of faces, emotions and faces, so on. In the case of images, basically talking about feature extraction. And then chapter 7 is in fact maybe most important from my point of view. It basically makes an argument for what I think, from my point of view, right, is maybe the single most important affordance, the single most important characteristics, or why should we use computers to look at culture. I mean, there are many other reasons. I don't want to deny them, but for me, kind of coming from visual arts, I was trained as an artist. I've been teaching kind of digital art all my life, right? But I do theory because I don't like to deal with curators, collectors, museums. You have to install stuff, and the art world is not the most intellectual world. So I just basically went into the kind of academic world. I can write something, put on my website, and I'm done, and talk to very smart people, like people in this audience. You guys are much more interesting to talk to than typical, collectors. Or collectors, I don't know. They're rich people, so they're smart. But curators, the art world is so much. It's like there's so much of. It's basically a big conspiracy theory, right? It's a big conspiracy theory that contemporary art is really important. That art can change people's lives. K-pop can change people's lives, or good design can change people's lives, not art, right? Anyway, so basically, here's the argument that the senses have emerged, right, billions of years ago. Right, all animals have senses, and the senses represent the outside world in terms of continuous features, right? So there's a loudness of sound, there's a pitch, we see differences in grayscale and color, and so forth and so on, right? So we can separate between millions of colors, not 16 millions like computer monitors can, but few millions. Even I think language emerges as much later, right? Somewhere between 50,000 and 200,000 years ago. So very recently, as a kind of add-on, as a secondary operating system, right? Which I think is trying to complement senses and to do what senses can do very well, right? So senses are about continuous representations, whereas language is about discrete representation. It divides the world into categories, chairs, tables, Denmark, Sweden, Finland, and so on. It kind of has this Platonic ideas. There is a general idea of a chair, in particular chair. We can talk about future and the past. Even in humanities, right, we have been using for thousands of years language to talk about culture, which is analog. And that's a big contradiction, right? So how can we adequately describe dance, film, rhythm, repetition, various patterns, the space in architecture, the taste of food using language, because language is not designed for it, right? So the sciences, since the Renaissance in the West and earlier in the Arab world, has moved to numbers. And numbers, of course, is what allows scientists to make lots of progress, right? Because the numbers allow us to capture the world in terms of continuous scales. So, for example, I can represent the mass, the position, the movement of moon, right, using the scale of 1 to 10, or 1 to 100, or 1 to 1 million. And I can also use numbers to represent continuous analog properties of culture, right? So when I extract features, I create this much more truthful, much more delicate, much more kind of realistic representations. And that's, to me, is in fact perhaps the single best reason, from my point of view, of using numbers, mathematics, and digital representations to represent culture. What we do with numbers, that's a kind of secondary, right? That's a secondary question. And here we use our methods which already exist in data science, but be able to represent the culture using this different semiotic system is what I think really matters. And then the last part, right, is a bit less general. So the last part is more specific to analysis of visual media and visual culture. Some of you know the projects are lab. Over about 13 years, we created over 42 projects with different data sets, including things such as Selfie City on Broadway. So some of you know these projects. So this focus on analysis of visual media has been our focus. especially because when we started around 2007, the digital humanities was still very much focused on text. There is now, just in the last few years, right, there is more work in digital art history. It's like an emerging field. It's developing also very rapidly, but for a while, nothing was going on. So the last part is really about visualization. So there's a kind of theoretical chapter about the history and theory of visualization. And then there are a couple of chapters about particular visualization techniques, which we use in our lab. And again, connecting them to, for example, the modernist art, talking about them as a montage and so on. And then there's a conclusion, which to me is equally important to the rest of the book, because this is where I have my new ideas, but I kind of felt I should write this book. It's a kind of textbook, right? And I'm very much looking forward to people, right, who will start using it. If you try to use it in your classes, please send me feedback, because the idea was to create a kind of textbook and to kind of take people through the same typical path I think we all go through, and our students go through when we do projects for cultural data, right? So first you kind of try to explain to students why is it interesting, why we should use the culture of computers and mathematics, right? And what are the different models can we use? For example, maybe we can arrive at some cultural laws like Newton's physics, because we have so many objects, or maybe we should use simulation, right? Artificial life, for example, as a model, or maybe we should use pattern recognition, which of course is the dominant model of data science today, right? Recognizing patterns in large data sets. And when you say, okay, where are we going to get our cultural data? Maybe we're going to look at the artworks that museums have digitized, or for example, we can go to MoMA, Museum of Modern Art in New York, which published a list of all its, I think like 1,800 exhibitions for its almost 70-year history. So a list of exhibitions is a cultural data set. Or maybe we can look at K-pop and K-pop videos, such as Teams Group has been doing, right, or folk tales and so on. Or maybe we can just tell the students to go outside, take a notebook, and simply kind of record their impressions of everybody else who passes by, right, through this corner. I mean, you don't need to have computers to record data. And when we think about sampling, right? So again, how do you represent, for example, contemporary fashion in Denmark? How do you represent phenomena of new Nordic cuisine, which you guys are very responsible for, right? Which became like really one of the ingredients of global culture now, right? What does it mean to represent youth culture today? What does it mean to represent Instagram? So questions of representations come to the front. Yeah, and when we figure out how to describe our data, do we use categorical variables? Do we use continuous variables? What is the metadata? Should we question the metadata which comes from a data, which comes from a museum? Like what features we're going to extract? And then we're basically going to start probably with exploratory data analysis. We'll calculate some descriptive statistics, and also we'll start doing some visualizations. But in the case of visual media, these visualizations perhaps are not only kind of temporary tools, but they also can be final outputs, because as I argue in the book, and some of you know this argument of mine, I repeated it many times, is that if we kind of visualize visual media using traditional techniques and reduce visual media to bar graphs, pie graphs, line charts, and so on, we throw so much information. So we have been promoting this method with I call media visualization, where we include samples of images and video in the visualizations. And when we published a paper while wondering, did it all make sense? So I don't know, Mats, I don't know how much time do I have. Do I have any time left, or?
Not really, but take a few minutes.
Not much, yeah. So I think,
yeah.
Well, I think I will basically. I think it's enough. So maybe I'll just show like 2 slides. So I want to just take 2 minutes and to show you like a bit expand on what happens in the book conclusion. And that's of course beginning of some new book or series of articles I'm going to do. Okay, right. So just 2 slides. Okay. Oh, this was okay. Okay, good. Yeah. Okay. So so this is what I see. Again, for me personally, I'm not saying for everybody, but for me personally, in my own kind of personal cultural analytics journal, this is what I see. Sorry, guys, it's just a bit of a. My laptop is very small, so if I make the screen visible, my cursor disappears. So let me show it like this. Yeah, that's what I see for myself is a main challenge in studying contemporary culture with data science. Okay? So I think all statistical and data science methods today more or less, are based on aggregation and summarization. You reduce data. You go from 1,000 numbers to 10 numbers. You go from millions of images to 1,024 features in convolutional networks. You extract topics, right, from a set of text. It's aggregation and summarization. And that's what I decided I want to question. So shall we aggregate big cultural data and reduce it to a small set of patterns, right, such as frequently occurring ideas, frequently occurring themes, styles, behaviors, and so on? And that's the statistical paradigm which comes to us from the 18th century, standard today in data science and data-driven research. So this kind of paradigm focuses on what is common between a number of objects. It doesn't include what occurs infrequently. And I think this applies perhaps less to very nuanced studies, such as what Tim has been doing, but it definitely applies to a kind of mainstream data science. So here's, for example, a paper from 2017 where we took 100 million photographs from Instagram, and they wanted to study, what people wear in different cities worldwide. And then you start reading through a paper and you see this kind of series of aggregations, right? And omissions. Identify common combinations. Identify styles which appear more frequently, right? And then, by the time, we get the results, that's what we found, right? So using machine learning, computer vision, we found, maybe a couple of hundred or perhaps less, these kind of common styles. And then we identify where the styles appear, in what months, in what cities worldwide. And it's wonderful, but it's also completely, in a way, describes only mass culture, right? So when you can go from 100 million photographs, right, which correspond to about 50 cities, and you start aggregating and summarizing and reducing, like all the favorite terms of data science, that's what you end up, right? You end up with people who wear white t-shirts with some kind of slogan, or women who wear red dresses, and you basically get rid of, people who wear something very different. You get rid of subcultures. I don't see any bikers. I don't see any fashionable people wearing all black. I don't see any fashionable people wearing, kind of black Japanese fashion, right? Yamamoto. I basically don't see kind of contemporary culture. What I see is like a mainstream, right? And I think this is my criticism of cultural analytics, as it's often being done within computer science, but also often in humanities, is that by automatically applying this logic of reduction, aggregation, getting rid of outliers, what you get rid of is actually most interesting things. So in the case of contemporary fashion, right, you maybe go to a store and there's 100 white t-shirts, and they all to computer look the same, because that's what we how program a computer, but to the buyer, to the users, will look different, right? The t-shirt may have some small name here, another one may have small button here, another one can have something else. So the contemporary consumer culture corresponds, the contemporary consumer culture operates by small differences, because there are so many objects, right? So many food, so many restaurants, so many Nordic food restaurants around the world, so many organic, t-shirts, that the designers, restaurants, hotels, musicians operate by creating very small differences. And I think what we have to do is start teaching our computers how to recognize the small differences, because that's how contemporary culture works, right? And this is my kind of second slide and the last one. So shall we refuse this dominant paradigm, instead focusing on diversity, variability, and differences, including very tiny ones? So that's what I think, for me personally, is my next challenge of cultural analytics. Now that cultural analytics achieved, I think, lots of success. And Tim, I mean, you just look at Tim's work and work of many other people, but that's, to me, is the next challenge, how we can work on big cultural data without aggregation, right? So how can we include everything? How we can identify small cultural islands? How we can question similarity, right? Because similarity, right, the measurements of similarity is what behind, automatic analysis of categories using machine learning, clusters, dimensional reduction, and so on. So how can we create a new science, if you like, or discipline of, right, when you kind of paradigm for study of human culture and also human society, which only focuses on differences and basically get rid of categories. Various categories is like Marx, right? Modes of productions and dividing the world into classes, or perhaps the binary gender categories. And here industry is quite ahead, right? So Facebook allows you to, I think, you can select one of 22 or 23 like kind of sexual identities. So that's already right quite a good result. But if you look at the social sciences, we still divide people into few demographic groups or into few age groups, or by country, and we have to get rid of it, right? I think we have to use our computers to their full capacity, and we have to think about how we can analyze billions of cultural expressions without categories at all, using continuous features, or if we could use categories, how we can use millions of categories, what we biologists do when we talk about biological species, but not few categories, as we're still doing humanities and social sciences. So that's, to me, is the next, perhaps my personal, but if you think it's a good idea, please join me, like this next impossible task for cultural analytics. Thank you so much. I hope I didn't take all the time like I usually do, and we do have some time for discussion.
We certainly have, and thank you so much. What a wonderful introduction to your book and to the field as such. We have time. I'd just like to say also, I mean, I think you also demonstrated the way that Tim does, that it's both a matter of an interesting method. There's a world of data that is in need for humanities engagement with data of a scale that we haven't seen before. And on the other hand, particularly on focusing on diversity, and which is also one of the passages in your book I really notice, is there's a strong political commitment saying, well, this is important because we have to understand diversity, the world we live in, particularly if you have a view of the world where you think that that is a good idea, that we need to promote that, we need to understand it as well.
Right.
So I think that's
well, I want to say, what I so much appreciate it, because I think, and I appreciate you got this message, because what I'm really worried about is that today we have lots of discussion about diversity, but at least, for example, in America, as you know, right, diversity is meant, in very, very particular kinds of diversity, right? Inclusions, gender inclusions, minority inclusions, etc. But what about millions of artists who never included in our canons, right? So to me, diversity simply means recognizing full range of variability, like almost in a biological sense, but also potentially having a cultural history where we include everybody, right? Not only people who are excluded, but even men who are excluded as well. Sorry for interruption, but I was just excited that you got this idea. So yeah.
Certainly, yeah. So feel free to use the chat, raise your hand, and ask questions for both Tim and Lev. And I'll just pause for a minute before I ask one of the questions I have been thinking about. And that has to do a bit with okay, so there's a question from Maya. And you can read it in the chat. It's for Tim. And what do we learn about the people and the environments who engage in conspiracy theories from your analysis? Can you pick up on that, Tim? And then Christopher has a question afterwards.
Okay, yeah, that's a wonderful question, and I think there are a couple of dimensions to this. So there's a low trust environment. There's also a low access environment. So when if we look at 19th century rural Denmark, there's a pretty low access to information. A lot of the information is going to be accessible through either sermons on Sundays or through community engagement, or basically just talking to your neighbors. Maybe you're at the mill. And then one of the things that people are most concerned about in late 19th century rural Denmark, you've got a shift to these very small farms that are on very unequal ground, and they have some very narrow bands of productivity. And so people are trying to figure out why is Jens Thomsen doing so well over there? Why am I doing so bad? And part of it might be that, Jens has, some sort of magical quality. Maybe he's made a deal with the devil, or maybe he has a Nissa at his farm. And maybe I'm just being victimized by Stu Khan, who lives down over there in Sturhusen, and she has basically bewitched me, right? And so now I've got to figure out some sort of strategy. So that's a perfect opportunity for people to start to, hey, have you experienced this? It's like, oh yeah, I had a problem with her too. What should we do about it? Now, something that I'm really interested in is the penetration of newspapers and media, but also the radio. At what point does even this low level, because the age of witch persecution and burnings is hundreds of years in the past by the time these people are telling you stories. Why are they telling you stories about witches? Well, it's a low level type of economic threat that they're trying to figure out. But I think the advent of, access to more consistent and more even information, which really takes over when you get the radio and consistent newspapers and things like that. And then we see a complete dissolution in this belief in witches. Birgitte Rørbye noticed that there was some kind of competition between klogefolk or healers, folk healers in the countryside, but that all dribbles out by the 1920s. And of course, the rise of market towns transitioning into more sort of multifaceted cities and things like that. So there's something going on there where access to information and trust in information and literacy, education, all of those things start to undermine the need and the meaning-making process of a lot of these stories. Now we find ourselves in another situation where deliberately people have undermined our trust in otherwise trustworthy information sources. And instead of having not enough information or no access to information, it's like trying to drink water from a fire hose. We've got way too much information. And that can also paradoxically lead to a lack of information, right? So that's what you see with all of these information channels. And now with a lot of these stay-at-home orders, you're winding up sitting in front of the computer, 6, 7, 8 hours a day. And there's just sort of a constant buzz of just stuff coming by. And now you start to distrust all of your previously trusted information sources. And so we're kind of set back into this very odd situation where while we have access to all of this information, we've got many, many people around us distrusting that information. And we're being exposed to ideas that even if we don't believe them, we've been exposed to them. And as soon as you're exposed to an idea, you are susceptible to that idea. You may not believe it, you may reject it, but at least now it's out there as a subject of debate. And so what do we learn about the people? I think that's getting to Lev's idea of specificity. And so in our work, we recognize that one message does not fit all. And so we've been looking at anti-vaccination and vaccine hesitancy and realizing that if we're going to work productively in many different types of communities, we have to understand those communities as specific, right? That it's not, oh, all Americans think this, not at all. It would be, as if I were to say, oh, all Danes believe X, and, we know that to not be correct, right? So there are these micro communities, and each of those communities have fears and needs that we have to address if we're going to work productively with them. I hope that addresses that question.
All right, Christopher, you had a question, and then there's a question also on the chat. I think Lev is already reading it from Ellen Rees. But Christopher, would you pose your question?
Okay, yes. Is it okay that I do it over the mic?
Sure.
Thank you. And thank you for very interesting presentations. And maybe it's 2 comments, but there are sort of implicit questions in it. First, to Lev's idea that you want to move away from aggregation. I think that really the problem here is that you're looking in sort of standard statistical learning for that solution. I mean, the solution is in a way already there. Look at the dynamics, the complexity, the self-affinity of these systems, and you will find these patterns of variation that deviate from the mean, or whatever way you want to represent the system under scrutiny. And following that, with the same idea, sort of, Tim, turning to your approach, I'm wondering specifically your conspiracy theory. In a way, big data are uninteresting, right? They're completely uninteresting to anybody except from people in high performance computing, right? I mean, it's really what you want is to extract some patterns. You want to, in a sense, find the correct compression, the correct reduction that can help you solve your problem. The price of that is that you lose causal control, but that's all right for at least our humanists to do so. What I'm wondering is content really relevant, Tim? I mean, when you study conspiracy theory, isn't it just more relevant to essentially see sort of the informational distribution, maybe the variation, or even the reproduction rate within certain sort of certain, for instance, online fora? I would guess that the reproduction rate of ideas or content would be much faster, but maybe also deteriorate faster for conspiracy theories compared to conspiracies. And I wonder if what you really want to find is essentially the sort of underlying or sort of very few state variables that, in a sense, characterize the system of conspiracy theory. You hinted at this yourself, because you said that the eliciting conditions in US, or you argued that were sort of the low trust, low coherence. But then you have to explain, how come conspiracy theories become interesting or relevant in Denmark? We have high coherence, we have high trust, we have all these sort of, yet conspiracy theories at the moment, they flourish in the sort of as sort of a function of COVID-19, or in response
so, I
to
mean,
COVID-19.
I think you've got two points there. One is this last question: why do we see conspiracy theories in a place where allegedly we have high trust, high access? And then the first part, which is actually trying to estimate the underlying parameters of this generative narrative framework. And that's exactly what we do, right? We're trying to find the actants and their relationships that are consistently at the basis of this generative model, so that something like a conspiracy theory can be negotiated by a group of people over time. And it turns out to be a very short amount of time. And then this becomes a stable generative framework that people internalize, right? They know who the actants are, they know who the relationships are. And this model then allows us to actually, if we go back to 19th century Denmark, generate a story that would be, acceptable if we put semantics on it to a 19th century Danish husmand. Or if we look at something like Reddit or 4chan, we could generate comments that would fit right into whatever forum is discussing the fact that Hillary Clinton is trafficking in babies so that her and her Democratic friends can eat their hearts and live forever, right? So you're right, there is some underlying stable narrative framework. The problem is, of course, at this large scale, it's occluded by all of the noise. These forums are very noisy. I would suggest that in response to your second question, while there is seeming trust in institutions and media outlets like DR or Politiken or Jyllandsposten, that there's also a huge amount of or a much greater amount of jitter in this system than there was before, partly because people are spending much more time in these online communities. And recall that if you're exposed to an idea, it's now a possibility. And with that jitter is almost a feedback mechanism. So I think the stable foundations of the Danish free press are probably being compromised or at least challenged by this building wave. And we're no longer talking just locally, we're now also talking internationally, where a lot of these conversations are taking place in a multilingual environment. So that could be leading to this. It's not as if Denmark has been free from conspiracy theory or narrative about outside threat and strategies for dealing with it. And even looking at the 19th century stuff, we're able to see this alignment of different domains of human interaction. So that's really where I think that's where my thinking is going at this point.
Thank you, Lev. Would you pick up on that and perhaps also answer Ellen Reese's question
Yeah,
in addition to that?
Sure. Yeah. So in thinking, where I'm coming from and where I want to get to, I'm thinking about 1960s, right, which was the most radical time, I think, in human cultural history, where people had very visionary ideas. So you have McLuhan, who talks about technology extending our senses. But then we have more interesting thinker, right, which is Douglas Engelbart, who wants to build a computer system which would augment human intellect. And I think we're at the point where we have to do it again in new ways. So think about human evolution again. The senses are amazing instruments. They allow us to recognize one face in a million. We also fall in love with particular face, or particular landscape, or particular corner, or particular cafe, because it's just slightly different from millions of other faces we have seen in our lives. So human senses under some conditions can deal with variability, diversity, complexity. But they didn't allow human beings to really become who we are, right? So when the language comes in, if you kind of follow this, this theory, which is maybe not correct, but it's convenient in this context, the language comes in, which is really about aggregation, right? So instead of talking about every chair, you can talk about the idea of a chair, and right, and the language allows us to talk about best to one, and I think it's really the language of kind of human cultural civilization, right? And then now we have computers, and I think if you look at the industry systems, we're actually much more theoretically advanced than what we do, I think, in the academy, right? So Google doesn't decide we're going to aggregate the web, and every time somebody searches for something, we're going to give you one of 10 pages. We're actually trying to index, right, billions of web pages. Spotify, right, wants to extract features from 50 million songs. So there's a recognition that every song is unique. Yes, we're not capturing full uniqueness of every song, because we're only extracting 14 features from every song, every soundtrack, but that's already more. And when we build it with customized, right, listening list based on very parameters, which can have any selection from its 40, 50 billion songs. So I think that the way the computer systems are actually used sometimes in the industry is really future of humanities, because there are models in this industry, unfairized models, which allow people to represent much larger complexity, right? And between many, many more objects. So the person who asked me a question or commented, he says, he also mentioned, I think we have to find the right reduction. Yes, sometimes we do. Sometimes we want to find the right reduction. We want to find the right pattern, the right law. We want to identify the right conspiracy theory among millions of posts. I'm completely with it. But if humanities have a future, I think one of the things it should do is really figure out how not to have reduction, right? How to think about culture without any reduction. Or if you start reducing things, if you start with 1 trillion artifacts and you cluster it into 1 billion, you have to immediately calculate and theorize what has been lost. Again, this is my intuition. I'm not a prophet, but I do think that this is one of the futures, and people have also pointed me out, said, Lev, yes, there are certain methods which you may be not aware of, such as context learning and neural networks, which can do it. And maybe I'm not reading the right articles, but I yet have to see a single article in any journal in humanities or science or nature +1, which will say, let's look at 1 billion or 1 million Instagram photographs in terms of 1 million topics or 1 million styles or 1 million themes, as opposed to this kind of global reduction, which you could have already done in the 18th century. So again, that's my intuition that we'll see more work on this topic in the next 15 years. And in 15 years, we can see if I'm right or not. So, about the canon. Sorry, very briefly. Yeah, so a thing about the canon, it's actually a very complex thing. So there's a book published by a very interesting Cornell University psychologist, James Cunning, who also published a bunch of papers about computational analysis of cinema. So he worked with his students for a number of years and published a book, like a big book, which is about formation of canon of Impressionist paintings, right? We basically found out that the Impressionists, right, in France, they made about 13,000 pastels and oil paintings in real lives. And when we look at, let's say, hundreds of books on Impressionism, 95% of his books only reproduced the same 113 paintings. So to figure out how with 113 paintings, as opposed to our 113 paintings, became a canon, he actually had to investigate it for a few years. It was a combination of, lots of different historical kind of elements and whole networks. So I'm not sure we can easily, right? I mean, I'm sure you can do some computational analysis of canons and identify some larger patterns, but to actually figure out why there are particular works in particular canon, it actually would require, I think, lots of work. So it's actually not so simple. I don't think we can just simply reduce it to some formula. So that's my comment.
All right. Time is running. Thanks for your extremely generous lectures, and also I really appreciate the generosity with which you address the work of each other, and I think that is well deserved. I already get comments from people who had to leave, but saying that this has been extremely exciting. I completely agree. I think this is really important. I think this is so intellectually challenging as well as methodologically challenging. The first slides Tim showed could take up a seminar for years, I guess, solving these problems. So I thank you very much for taking your time from different parts of the world, different parts of the day. Thank you so much for all those who listened. We have recorded the whole thing, and we really hope that this will be inspirational, and sooner or later, we hope to bring people around the world and hopefully meet Tim and Lev in real life, and perhaps share some Nordic cuisine or what have you at Aarhus. You're definitely most welcome.
And do you think you'll be able to book? Do you think you'll be able to, I think you have to immediately start booking a lunch appointment, in very new restaurant. I forgot the restaurant name. You know what whom I'm talking about.
Noma.
Yeah. Although I think today will be disappointing, because one of the things about growth of culture, 6 years ago you had to go to Noma. Now you can go to thousands of places like this in every country. I mean, almost like this, and that's a thing. But it would be still interesting to see if Noma has something really special to offer. And anyway, but there are many wonderful other things. So there are many other wonderful. Or maybe we can just have our own Noma cookout. And I'm sure get all the recipes online. Thank you so much for organizing it. Thank you to Tim for exploding our minds, and thanks for everybody for your challenging questions. And hope to see you soon, one day in person. And meanwhile, wear a mask and keep the cases low.
Absolutely.
Like we do in South Korea.
Good, Lev, and thanks to all of our audience. Lev, is always wonderful to sit and listen to your talks, and Matt's so amazing that you're able to pull us together, even though we're all hunkered down in different parts of the world. And a big thank you to everybody for spending their afternoon, early evening, or morning, or middle of the day, or middle of the night, whatever, with us. So thanks so much.
Yeah, you're most welcome. Thank you, and we'll stay in touch. And everybody, be safe. Bye-bye.